Hey gang, we are talking about real life trig situations. Real life trigonometric situations. And I'm not going to get into anything specific, but I'm going to tell you what you need in order to solve these. So, first thing you need to do, read the problem. Everyone tells you to do this, but you really need to read the problem because that'll lead directly into the second thing that you need to do is draw a diagram. Now, there will be two types of triangles that you'll get from this. You're going to either end up drawing a right triangle, or I'll just say a general triangle. If it's the right triangle, we're going to use sine, cosine, or tangent. If it's the general triangle, we're going to use two things. You don't know what they are yet. The law of sines or the law of cosines. And 3, label the triangle completely. Because if you don't, you're not going to know what sine, cosine, or tangent you're going to use, or how you're going to build the law of sines or the law of the cosines. Now, I'll give you an example of one of them. A ladder is resting 15 feet on the side of a house. The angle the ladder makes with the house is, let's say, nice round number, 32 degrees. How long is the ladder? Alright, so we have to read the problem. A ladder is resting 15 feet on the side of a house. The angle the ladder makes with the house is 32 degrees. How long is the ladder? Now draw the picture. Draw your house. There's your house. There's your ground. There's your ladder. Doesn't have to be accurate, but it needs to show the parts that we have. Now what do we know? We know this distance is 15 feet. We know the angle that's made with the ladder and the house. So we have the ladder, which is right here, and the house, which is right here. So we're talking about this angle right here is 32 degrees. And it says, how long is the ladder? So I need the ladder length. Well, in this picture, the ladder is equal to the hypotenuse, because it's opposite the 90-degree angle, which is made by the house and the ground. Now, if I look at this angle, the angle that I have, which side do I have? Do I have the opposite leg, which would be here? This is the opposite leg. But this is the adjacent leg. So we have to ask ourselves, alright, I need the hypotenuse. I know the adjacent leg. Which trig value is going to give me, or is going to give me the ratio of the adjacent leg to the hypotenuse. And that is going to be the cosine. So I know that the cosine of the angle, 32 degrees, has to be equal to the adjacent side, the adjacent leg over the hypotenuse, which is equal to 15 feet over x. So I have cosine of 32 degrees is equal to 15 feet over x. Now, I would recommend never actually calculating the cosine until the end of a problem. And this is essentially a proportion problem because you have that over 1. So I could do a cross product. If you do the cross product, you'll get x times the cosine of 32 degrees. That's equal to 1 times 15 feet. And now to solve for x, I have to divide by the cosine of 32 degrees and divide that side by the cosine of 32 degrees. Those divide out, and I'm left with x is equal to 15 divided by the cosine of 32 degrees. Now, at this point, unless you have a table of values for the cosine, this is a calculator problem. And what you want to make sure is your calculator is in degree mode, not radians. Radians are something totally different. So let me move that up a little bit. Let me get my calculator. Calculator kind of got booted out here, so give it 1 second. Sorry about the delay, but here's the calculator. You could just fast forward to this point. Give it a chance to boot up. Always needs a chance to boot up. Let me zoom it out a little bit. Then I'll zoom it in. Eventually, it'll boot up. Here it comes. Any second now. Any second now. There it is. All right, I'm going to go to a calculator screen. So I want calculator screen, and I want to create a fraction, and in the top I want to put 15, and in the bottom I want to put the cosine, so I have to hit the trig button and go to cosine, and I want to put 32 and hit enter, and I get 17.9808. So what I get out of my x is 17.98. And that's 17.98 feet. And I didn't check to make sure that this was in degree mode. You can always just click out of here, go over to settings, and you can check handheld settings. That doesn't do it, so you escape out. You always have to play around with this. Go to document settings. Maybe that's it. Oh, and there it is. Oh, angles were in radians. That means I didn't get the right answer. So I had to change degrees. And I want to make this my default because all we're going to be doing in geometry is working with degrees when we're dealing with this, so I make it my default. And now I go back to 4, and I redo this, 15, and then I put cosine of 32, and if you really, really wanted to, you could have done this. You could have gone over to this and actually put in 32 degrees, 0 minutes, 0 seconds, because we got to cut degrees up if we need to, and I get 17.6877. So actually, this is close, but it's not accurate. I need x to be equal to 17.6877 feet. And we usually round to 2 places. And my ladder is 17.69 feet. So that's just one example. Big thing is, make sure your calculator is in degree mode when you're working with degrees. Or make sure when you type in a number, you type in the degrees.